Alright guys, welcome back to some more graphing quadratics. Alright, so today we're going to be taking a look at a different form, alright, that you might see quadratics, and we're just going to learn how to graph that. So our I can statement for today is I can graph a quadratic equation in vertex form. Okay, so when we took a look at graphing last week, we were looking at standard form, and this one is a little bit different, as you can kind of tell by the giant box down below. All right, so let's take a look at that. So a quadratic is in vertex form if it is written in the form we have a times x minus h squared plus k. All right, where the vertex of the quadratic is at h comma k. So your h and your k actually tell you where the vertex is, so you don't have to go hunting and looking for it like we did last week. Okay, so we're just going to take a look at some of the other letters and what they might do. All right, so real quick, we have our parent function over here. This is just straight up x squared. Nice little upside down St. Louis arch. All right, we already said that our vertex was at h comma k. Our axis of symmetry, if you remember from last week, that's at an x equals, and that's going to be your x equals h. So the h from your vertex is the same as your axis of symmetry. Okay, first letter we encounter, all right, just reading a vertex form equation is a. All right, so what is this? What can this do? All right, this can flip over x-axis if negative. Okay, so if the a is negative, it would end up going down. And then it also, we have a vertical stretch slash shrink. All right, so we have a stretch, oops, can't spell, if a is greater than 1, shrink if, all right, a is between 0 and 1. Hopefully that you get that down. Okay, the next letter we have to look at is h. All right, this is a, if you want to think about it, horizontal shift. All right, left slash right. All right, and remember, this is inside the parentheses. We kind of dealt with this before. It's the opposite of what you think. Okay, so if you have a minus h, so if you have a minus 2, you really need to go 2 to the right. If you have plus 2, you go 2 to the left. Okay, the last letter we have here is k. All right, this is a vertical shift. All right, and that's just straight up slash down. Okay, and this is exactly what you think. Okay, so if we have plus 2, then you need to go up 2. If it has a minus 2, then you have to go down 2. Okay, so we're now going to, all right, take a look at some examples, and then you have some to do on your own, and then we'll come back and we'll do some more examples to close it out. Okay, so if you flip over to the next page, all right, All right, some things, all right, that we keep in mind to make a nice basic parabola. So we're going to graph the vertex, and then we're going to use the A as the rise for our parabola. Okay, so our vertex, all right, if I take a look right here and here, okay, I'm going to do the opposite of -3. That's where my x is for my vertex. So the opposite of -3 is +3. And then this is my y, and it's exactly as it is, so it's 1. So 3, 1, that is my vertex. So I'm going to go ahead and plot that. Okay, your axis of symmetry, like we said, is your x-coordinate of your vertex. So we're going to say that x equals 3. And then on the graph, the way we represent this is with a dotted line straight up and down. All right, and then for the y-intercept, all right, all we need to do here is plug 0 into x. Okay, so if we get rid of that, we have 2 times -3 squared plus 1. -3 squared is 9. 9 times 2 is 18 plus 1. That is the y-coordinate of our y-intercept. All right, and that's because we plugged in 0 into x. So 0, 19 is our y-intercept. Okay. Now, we have our vertex and we have our axis of symmetry. What we need to do now is plot 2 more points to give us the basic shape of our parabola. Okay, so what we do is, all right, we take a look at this 2 here. That means we go up 2 and then out 1. Okay, so from the vertex, I'm going to go up 1, 2, and then 1 to the right, 1 to the left. And that's it. That's all we needed to do here. All right. Now what we need to worry about is transformations. All right. So normally your vertex is at 0, 0. So what we did here, if you want to take a look, we went right 3, up 1, okay, and then this 2, all right, like we said before, it ended up making our graph longer up and down. So we're going to say a vertical stretch. And that's it. All right. Nothing too over the top complicated with this. All right, so let's go ahead and move on to the next one. Okay, so we're going to identify each piece and graph it. So take a look at the vertex first. So the opposite of what's inside the parentheses. So we have -2, and then exactly what's outside of the parentheses, -1. Our axis, I'm going to plot that -2, -1. All right, our axis of symmetry is at x equals the x-coordinate of our vertex, -2. And then I'm just going to draw a dotted line down that. Our y-intercept, again, we're going to plug in 0. So I have 2 squared times -3 fourths, if I can write that, plus -1. So I have -3 over fourths times 4. What's 3/4 of 4? It's -3. Then I have -3 minus 1 equals -4. So that means my y-intercept is at 0, -4. All right. Now I'm going to graph it. Okay. So this time my A is -3/4. So that means I'm going down from my vertex. Okay. But when we go down, we're only going to go down 3/4 of a point. So not a whole point, only 3/4. And then we'll go out 1. and then it'll look something like that. All right, so this time, all right, we have 4 transformations. That's the most you can have. Okay, so remember, your vertex normally is at 0, 0. So we went left 2, we went down 1, okay, and then because we are going down now, we're going to say, all right, flip, just to keep it simple. And then the last thing we did was, because that was less than 1, okay, it is a vertical shrink. It shrunk vertically. Okay, like I said and mentioned many times before, if you have questions, all right, go and hit me up on my office hours. Okay, so you've 3 to do on your own real quick. Pause it here, do those, and then come back and we'll do the last few problems together. All right, so we're back with the last 3 examples. All right, and these are looking at some cases where you don't have all 3 letters. So you don't have A, H, and K. You might have one of those missing. So we're going to take a look at that. Okay, so for this next example, number 3, all right, we still have a number inside the parentheses and behind the parentheses. All right, so that doesn't change how we find our vertex. All right, so the opposite of 5 is -5, and then -4 is just like that. So I'm going to go 1, 2, 3, 4, 5, 1, 2, 3, 4. All right, my axis of symmetry is that x equals that number right there, -5. All right, and then my y-intercept, all right, if I plug in 0 for x, that just leaves me with 5 squared plus, or minus 4, my bad. So I have 25 minus 4, 21. And that's my y-coordinate. So I have 0, 21 as my y-intercept. I also forgot to do the axis of symmetry. Okay, so because we don't have an A in front, from our vertex we go up 1, over 1, both directions. And then we just do that. Voila. That's all we had to do. So because we didn't have an A, we didn't stretch or shrink it. We just have to worry about how much left and right or up and down we moved it. So if we start at 0, 0, and we went to -5, -4, all right, we went left 5 and down 4. And that's it. Ta-da. Easy peasy. All right. That one was, I think that one's the easiest because you don't have an A. Example 4, okay, we don't have anything in parentheses here. So that means we don't have an H. So that means, all right, our vertex is at 0 and then plus 1. So if there's no H or K, then that coordinate that it's related to is going to be 0. So because we didn't have an H, all right, our x coordinate for our vertex is 0. All right, our axis of symmetry is that x equals 0. And I'm not going to put a dotted line. Actually, I will. Hopefully you kind of see that. All right, and then our y-intercept, when we plug in x equals 0, that just cancels out, and we're left with plus 1. And we already found it, actually. It's our vertex. So 0, 1. All right, and then it's got to plot some points. So this 1/4, that means we are going to go up 1/4 and then out 1. So it's going to be, a lot wider than you might think. Okay, so this plus 1, that made us go up 1, and then the 1/4, that was a vertical shrink, just because it's a fraction. So again, only 2 transformations there. Let's take a look at this last example. All right, and then you can go ahead and start on your homework. All right, so for your vertex, all right, we don't have a k out back, so that means it's going to be 0 in the y-coordinate, and then the opposite of -3 is +3. All right, our axis of symmetry is at that coordinate, x equals 3. And then our y-intercept, remember we plug in 0 for this. So it's -3 squared, and then that's times, or -6 in front. So we have -6 times 9, -54. Woo! So 0, -54. I'm going to plot my vertex, 3, 0. And that's my axis of symmetry as well, so I'll just draw dotted lines down it. All right, and then because we have a -6, from that point we go down 6. 1, 2, 3, 4, 5, 6, and then 1 on either side of the axis of symmetry. And that's it. We graphed it. Now just a list of transformations. Okay? So with the vertex, we went from 0, 0 to 3, 0. So we went right 3. That's our first. All right, and we're facing down this time. So we did a flip. And then, if you notice, it's a lot skinnier too. So this is a vertical stretch. And that's it. All right, if you have any questions, email me or come in during my office hours, which I will have posted. But if not, that's all. You will have a quiz that I will put out later in the week. To those of you that are listening and watch all the way through, thank you. I appreciate that. But I'll let you know the details of that when I come to finalize those. It'll be out for sure. So you can get it done Thursday or Friday. Yeah, it's up to you. All right. Have a wonderful week. Hopefully you had a good Easter and a good 4-day weekend. See you in the next one.